Welcome. Today is part 2 of the chapter Theory of Quadratic Equation for preparation of joint entrance examination main and advanced, and also for different state level joint entrance examination. Today is part 2 and first problem is problem number 4, and it is if A, B, C are all real, then the roots of x minus b, x minus c plus x minus c into x minus a plus x minus a into x minus b are always, first option, both positive, both negative, all real, all imaginary. So the question is, if ABC are all real quantities, then the roots of this equation, this is equal to 0. Then the roots of this equation are both positive, second option both negative, both real, both imaginary. Actually, the equation become, after multiplying these three, it is actually x square minus b plus c into x plus bc plus x square minus a plus c into x plus ac plus x square minus a plus b into x plus ab is equal to 0. So it is equal to 3x square minus coefficient of x is b plus c, c plus a with negative sign, a plus b. That is 2 times a plus b plus c into x and plus bc plus ca plus ab is equal to 0. So as per options, first time check whether it is real or imaginary. First I will check it. To check whether it is real or imaginary, to study nature of roots means value of the discriminant. The discriminant actually d, it is equal to b square, that is 4 into a plus b plus c whole square minus b square minus 4 into a into c, 12, that is 12 bc plus ca plus ab is equal to 0. Oh, it's not 0, the discriminant is this. Taking 4 common, it is equal to a square plus b square plus c square minus 3 into bc plus ca plus ab is equal to 4 into, another one is product terms, plus 2ab plus 2bc plus 2ca. Now it is a square plus b square plus c square minus ab, so it is a square plus b square plus c square minus bc minus ca minus ab. It is a very known expression, This is half of means 2 into a minus b whole square plus b minus c whole square plus c minus a whole square. Now it is sum of three quantities. Therefore, it must be positive or at least 0. So discriminant is positive or equal to 0. So only option is roots are real. Next, next problem is problem number 5. And problem number 5 is if alpha beta are roots of x square minus 2x into cos phi plus 1 is equal to 0, then the equation whose roots are alpha to the power n, comma, beta to the power n, alpha to the power n and beta to the power n. And options are x square x square minus 2x cos phi minus 1 is equal to 0, x square minus 2x cos phi cos n phi, sorry, this is also n phi plus 1 is equal to 0, x square minus 2x sin n phi minus 1 is equal to 0, sin n phi plus 1 is equal to 0. Here, one quadratic equation is given, x square minus 2x cos phi plus 1 is equal to 0, and alpha beta are its two roots. Then we have to find the equation whose roots are alpha to the power n and beta to the power n. Now solving this, we get alpha comma beta are equal to, I solve it with the help of Sridhar Acharya method. It is equal to 2 cos phi minus b plus minus root over b square minus 4ac by 2a. So that 2 will cancel. So it is equal to cos phi plus minus, taking minus 4 common, 2 will be there. It is minus root over of 1 minus cos square phi. So it is equal to I into sine of phi. Two cancels. So I can safely take alpha is equal to cos phi plus I sine phi, and beta is equal to cos phi minus I sine phi. So alpha beta we obtained. If we take alpha is equal to this and beta is equal to that, same result must be obtained. Now alpha to the power n Actually, this is this to the power n. So it is simply cos of n phi plus I sine of n phi, and beta to the power n cos of n phi minus I sine of n phi. Well-known theorem. So our required equation is x square minus x to the power alpha to the power n plus beta to the power n into x plus alpha to the power n beta to the power n is equal to 0. Now clearly alpha to the power n plus beta to the power n means sum of these two. So this negative part will be cancelled with that, so that it is equal to x square minus 2x cos of n phi, then alpha to the power n into beta to the power n. So this multiplied by that. So cos square n phi minus I square sin n phi, that is simply 1, is equal to 0. So the second option is our correct option. So that is our answer. Okay. Next, it would be problem number 6 of this chapter. Problem is the equation x square minus 3 mod x plus 2 is equal to 0 has number 1, no real root, two real roots, one real root, and four real roots. So this is a quadratic equation, but x is given as modulus x. We have to find the number of real roots, how much? 0 or 1 or 2 or 4. By previous method, what I applied in last class, this can be written as x square means mod x whole square minus 3 mod x plus 2 is equal to 0. Because x square positive, it are positive. And this can be written as mod x by factorizing mod x minus 2 into mod x minus 1 is equal to 0. So that we get either mod x is equal to 2, which gives x is equal to plus minus 2. So for this one, we get 2 real root, or this is equal to 0. In that case, mod x is equal to 1 gives x is equal to plus minus 1. So ultimately we get 4 real roots, 1 minus 1, 2 minus 2. So 4 real roots is the correct answer. So option D is correct. You can verify by putting 2 minus 2 here, 1 minus 1 here. You can see it. Or you can solve in that way also. First you take x is positive, then equation become x squared minus 3x plus 2 is equal to 0. So in that case, by factorizing, it is x minus 2 into x minus 1 is equal to 0. So roots are 1 and 2. I already obtained it, 1 and 2. Similarly, by taking x is negative, you get another, and we can accept 1 and 2, we can accept it because our assumption is x is positive, this is positive, this is positive. So we have to accept both. Similarly, by using that, we can obtain another two value, x is equal to minus 1 and minus 2. Anyway, you can adapt, you can take any method. I think this is simplest. So next problem. Now problem number 7. If alpha beta are roots of a square x square plus ax plus 1 into x plus a plus 1 is equal to 0. So alpha beta are roots of that. Then the value of alpha square beta square plus alpha square beta plus alpha beta square plus alpha plus beta plus 2. Value of this we have to obtain it. And options are alpha square plus alpha plus 1, alpha square minus alpha plus 1, 1 and 2. These are the options. So in this case, one quadratic equation is given, two of the roots is alpha and beta, to find this value. Now let us find the quadratic equation in standard form. It is actually a square x square plus, they together is ax square plus a square x plus 1 into x. Just 1 minute, 1, 2, 3, 4. Plus 1 is equal to 0. That is, equation is a square plus a into x square plus a square plus 1 into x plus 1 is equal to 0. So we must have sum of the roots alpha plus beta is equal to minus a square plus 1 by a square plus a, and alpha beta is equal to 1 upon a square plus a. We obtain this from equation. Now we have to find this value. This is simply alpha beta whole square, we know it, plus taking alpha beta common, alpha plus beta from these two, plus alpha plus beta plus 2. Alpha beta whole square means this is 1 upon a square plus a, alpha beta is 1 by a square plus a whole square plus alpha beta. Alpha beta means 1 upon a square plus a into alpha plus beta. So it is a minus sign would be there. A square plus 1 by a square plus a. Then alpha plus beta minus a square plus 1 by a square plus a plus 2. So that it is equal to 1 upon a square plus a whole square. Taking this common minus a square plus 1 by a square plus a, we get 1 upon a square plus a plus 1 plus 2. So that this is equal to a square plus a whole square minus this one a square plus 1 by a square plus a minus a square plus 1 by a square plus a whole square plus 2. Now we have to simplify it. From there, 1 upon a square plus a whole square, taking this and that, 1 minus a square plus 1 by 1. That is 1 minus a square minus 1. So I have taken this and that plus 2 minus a square plus 1 by a square plus a. They together is 1. So 1 that minus 1 cancels. So minus a square by a square plus a whole square minus a square plus 1 by a square plus a plus 2. So that it is equal to taking this and that together. Mistake হয়ে গেছে, some mistake happened probably. A square plus a whole square common, LCM, this is minus a square, and this is minus already taken there, so plus a square plus 1 into a square plus a, remember, plus 2. I think all a square will be cancelled. All a square, all a will be cancelled. That is still here. From this, and that. Achha, let us again simplify from that. I think somewhere I have done some mistake. So let's now try for another time. Taking these two together, 1 minus a square minus 1, so minus a square by a square plus a whole square. This and that together, minus a square plus 1 by a square plus a plus 2. Still, a can be taken common and that will be cancelled. So minus 1 by a square plus 1 whole square minus a square plus 1 by a square plus a plus 2, a square plus a. Anyway, uh, I think I have done some mistake somewhere. Answer would be, all a will be cancelled. Answer would be 1. You try for yourself. Answer will be 1. Next, problem number 8. Problem number 8 is the quadratic equation with real coefficients, one of whose root is 1 upon 2 plus root 2I. The quadratic equation with real coefficients and one of whose root is this. As coefficients are real and one root is complex number, other root must be its conjugate. That is, other root is 1 by 2 minus root 2I. If it is alpha, it is beta. So alpha plus beta would be equal to their LCM 4 minus root 2 I square, root 2 square I square, that is 6. It is equal to 2 minus root 2I plus 2 plus root 2I. Just 1 minute. It is 4 minus 2I square, 4 minus plus 6. Okay. So that this cancels. So that it is equal to 4 by 6, that is 3 by, 4 by 6 means 2 by 3. Alpha product of the roots alpha beta is this into that. So it is 1 by 6. So that the equation become x square minus alpha plus beta into x plus alpha beta is equal to 0. That is x square minus alpha plus 2 by 3 into x plus 1 by 6 is equal to 0. That is 6x square minus 4x plus 1 is equal to 0. This is our answer. Oh, I have not given options. Option is 6x square minus 4x plus 1 and other 3 are there. So this is our option. So okay, today let us stop and I request you to please like, share and subscribe my channel. Thank you.